I'm Anil Kumar, and let me first thank my subscribers for taking keen interest in my videos and posting excellent questions. Welcome to your semester. In the very first chapter on functions, you're talking about domain range and some application questions, right? So in this video, as I've got a lot of requests, I'll try to explain you how we can find domain and range when word problems are given to us, right? So I'll take a few questions to elaborate on it. Question number 1 here is, a ball thrown from a roof of 25-meter building reaches height of 45 meters above the ground after 2 seconds and hits the ground 5 seconds after being thrown, right? So that's a statement. You need to find domain range of this function, and you have to determine an equation for the function. So we are going to use concepts learned in quadratic equations and then solve this particular problem. Now let me first sketch and show you what really we are trying to solve. A ball is thrown from a roof 25 meters, let's say this is 25 meters, and reaches height of 45 meters. So we'll assume that this is the maximum height, right? So we are making an assumption. So when you say this, so we say maximum height equals to 45 meters. So we are making this assumption, right? So whenever you have kind of ambiguity in a question, be clear what you're trying to do and what you're assuming. So there is no harm in writing down your assumptions. So my assumption here is, when I say reaches height of 45 meters above the ground, means we are assuming that to be the maximum height. Okay. So the ball is thrown and kind of goes like this, reaches the maximum height, and then it has to fall sometime, right? Like this. So that's the path, and we call this as a projectile path, right? This point itself from where it is thrown is 25 meters above the ground. So this is the height of the function we are doing with time, and the units are in meters. And here we have time in seconds. The maximum height is reached 2 seconds after. Is it okay? So this is the maximum height. I hope up to here there's no problem. And after 2 seconds, or that is after 2 seconds, and hits the ground 5 seconds after being thrown. So this after being thrown from 0 to 5. We call this as 5. So we have, as you can see, a projectile path, right? So that means we are looking for a quadratic equation. Okay. Now we can write quadratic equation in different forms. So I'm trying to do part B first. Well, let's answer part A first, and then we'll move on to this. State domain and range of the function. That's the part A, right? So let me answer here A. What do you think is the domain of this function? So domain variable I've taken as t will be from 0 to 5. Do you see that? That is when the ball is in the air, correct? So the domain is from 0 to 5. Is it okay? How about the range? So range is height, correct? The variable height is for the range. Range is from, since it falls on the ground and at this place the height is 0 to 45. Is it okay? 0 to 45. Fortunately for you, both parameters, all the parameters required to find domain range are provided in the problem itself. So the example is kind of simpler than what you should be expecting, okay? So domain range we have answered. Now let's get into part B, which is to determine the equation for the function. So when you look at this path, it's a projectile path. Now we can use different kinds of quadratic equations to get to the solution. But if you know the maximum, the best way is to use the vertex form, right? So in vertex form, we can write that the height with time is a times, we don't know what a is, but t minus 2 when it comes to the maximum height square plus the maximum height itself 45. Do you see that? So that becomes an easy solution for the given situation, and actually this assumption helps us to get to this. Perfect. Okay, we'll assume and just move on. Okay, there are different ways also. You could use 3 points, 1, 2 and 3, because at 2 we have 45, at 0 we have 25. So I'll leave that method to you. So we have 3 points. We'll call these points as 0, 25, correct? And then we have 2, 45. And we also have 0, I should say 5, 0, okay, sorry, 5, 0, the x-intercept. So with 3 points, you can always find a quadratic equation, but I'm not getting there. I'll use with this assumption and get to the solution. To find a, we could use one of these points, correct? So either 0, 25, or you could use 5, 0, as you wish. You could use any one of them. So let me use 0, 25, okay? So the height is 25 to begin with, a, and t0 minus 2 whole square plus 45. Okay, so 25 minus 45 equals to, square of this is 4, so I'll have 4a here, and let's use the calculator. So we have minus 20 there, right? So let's do 45, so 25 minus 45 equals to minus 20 equals to 4a, and a is minus 20 over 4, which is minus 5. Do you see that? So that's what we get, and so we can write down our equation as h of t, let me write down here, h of t equal to minus 5 times t minus 2 whole square plus 45. Is it okay? So you get your equation. So this equation is in vertex form, correct? So you can get your equation like this. Well, I'd like you to find the value of a using the 0.5. And see, you may get separate value, you may get the same value. Also, try to find equation of this parabolic path using these 3 points. I hope you understand what I'm trying to say. You could start with the equation h of t equals to ax square plus bx plus c. 3 points will give you 3 equations, right? If I write 0 for x, I get 25 for y. So we get 25 equals to 0 plus c. So that gives you c as 25. Is it okay? Now if c is 25, we could write the equation as h of t equals to ax square plus bx plus 25, and now use the 0.5, 0, right? So if I write 5 here and 0 for this, we get one equation. 2 and 45 will give you the second equation. Is it okay? So we get 2 other equations, which is, if I write 0 and 5, one equation is 0, 5 square is 25, so we get 25a plus 5b plus 25. This is my equation number 1. And then equation number 2 we can get by using the 0.245. So that is 45 equals to 2 for x, 4, that means 4a plus 2b plus 25. Is it okay? So we get 2 equations, and from these equations solving simultaneously you can find a and b, and you'll get your result, which will be accurate and will be in standard form, correct? So you could get this solution also. So there are different ways of doing this question. However, for the given situation, with this assumption, I find that method to be the best. I'm Anil Kumar. You can always share and subscribe to my videos. Follow the method which suits you best. Feel free to write comments and share my videos with your friends. And if you like, you may put some likes. Thank you and all the best.